Okay, so what we have is just a plain old rectangular parallel pipe bed. Okay, with 4 vertices in the XY plane as labeled in an altitude of 5, right? And then we've got a density function. Okay, here's our density function. And density times volume is mass. Now, you can't just apply a single density to this because the density changes from point to point. Okay, but as William noted, it changes only in horizontal planes. So in every horizontal cross-section of this thing, okay, the density function has the same behavior, so you would have the same average density, right? So if you just find the average density in one of these planes, and it might as well be the XY plane, I mean, there's no Z dependence here, and I'm going to throw in a Z dependence later. Let's do this first, okay? So we find the average density. So strategy and it will be the same in all horizontal planes as they intersect. That's implicit, you know, the intersection of every horizontal plane. Okay? So the density down here has exactly the same profile as the density up there. So, are you going to find the average density in the XY plane? Well, the suggestion that was made is find the densities at the corners, right, and average them. Okay? Now, this function isn't linear, so you can't expect that to give you a completely accurate average density, right? And you can use what you learned in second semester calculus. Did you do double integrals? Yeah, it's a fairly simple double integral, but we'll set it up. I'm not going to assume that you remember the details since you don't even remember for sure whether you did them. Okay? They're easy enough if you understand the principle of setting up an integral, which is something we're going to talk about because it's central to this course. Okay? As central as anything. Anyhow, if you go ahead, find the density at the corners and average it, and then maybe just to see how well you did, find the density at the center point, which is easy to find, right? And see how that compares with the average you got when you did the corners.